Welcome to The Explainer. Today, we're diving into a data integration nightmare that, let's be honest, many of you have probably faced, trying to import hundreds of Excel files that are all just a little bit different. It's a problem that can suck up so much of your time. So, let's break down a much smarter way to handle it.
So, let's kick things off with a real-world scenario, something that comes straight from a developer on Stack Overflow. And honestly, this question just hits the nail on the head. It perfectly shows why those rigid, old-school data processes just fall apart in the real world.
And there you have it. That's the heart of the issue, right? You've got this massive pile of files, but each one has its own little quirks and differences, probably because they're coming from different people or different departments. It's organized chaos, for sure.
And here's what that chaos looks like up close. You see these small but absolutely critical inconsistencies? File A calls a column product name, but file B just has product. Sale_date becomes date. These tiny little differences are exactly what will break any simple one-size-fits-all import you try to build.
Okay, so your first instinct might be, well, I'll just create a separate import process for each of the 300 files, right? It seems straightforward. But trust me, that path is a massive trap. Yeah, this brute force approach is a perfect recipe for a system you just can't maintain. Building a unique package for every single file isn't a solution. You're just creating 300 future problems. I mean, think about it. If one column name changes, you have to go hunt down that one specific package to fix it. And what happens when file number 301 shows up? You're just signing up for more and more manual work forever. So if brute force is clearly a terrible idea, what's the smarter play? We've got to think differently. Instead of 300 rigid, fragile packages, we need to build one single, intelligent package that can handle all that variation.
And the secret sauce here is building a loop. The process points to a folder, it grabs a file, and, this is the most important part, it inspects the file first to figure out its structure. It reads the column names, the sheet names, and then it dynamically creates a temporary table that perfectly matches that specific file's layout before it tries to load any data. It literally adapts on the fly.
And that, right there, is what we call dynamic processing. Your process becomes intelligent. It stops assuming what a file should look like, and instead, it finds out what it actually looks like right then and there at the moment of execution.
So, how do you actually pull this off? Well, you use the tools built right into platforms like SSIS. For instance, you can use variables to temporarily store the unique column names you find in each file. Then you can use something called a script task, which is just a little piece of code, to do that detective work and inspect the file. You can even get fancy and use techniques like fuzzy matching to automatically fix common typos. Now, building a dynamic process like this is incredibly powerful. But look, it's not magic, it's not foolproof, things will still go wrong, which is why a truly resilient system needs to give you useful feedback. You've got to understand the messages it's sending you. Because when your automated process fails, and trust me, at some point it will, it doesn't just crash and burn. It actually tells you why it stopped using these specific error codes. Learning to speak this language is absolutely essential for troubleshooting. Now, these codes might look like a bunch of random jargon, but they're not. They're specific, helpful clues. For example, DTS E open package file isn't some deep mystery. It's just the system saying, hey, that file isn't where you told me it would be. Or DTS E variable not found means a script is asking for a piece of information it never got. These are your breadcrumbs to find and fix the problem. Okay, let's bring this all home. The real solution here isn't just about a technical trick or a piece of code. It's about a fundamental shift in how you design your data processes in the first place. The key takeaway is this. We're moving from a brittle approach that assumes every file is perfect to a resilient one that actually expects variation. Instead of hard-coding everything and then just watching it break, you build a single automated process that discovers a file structure and adapts to it. That's the difference between fighting your data and actually working with it. So, if you remember anything from this, let it be these three things. First, build one dynamic package that can handle any file, not hundreds of rigid ones. Second, let that process discover the file's schema when it runs. And third, treat those error codes not as failures, but as helpful feedback to make your system even smarter. And that really leaves us with one final question. The next time you're facing a messy data challenge, ask yourself this: have I built a system that's designed to handle the real, chaotic world, or have I built one that demands perfection, a perfection that's probably never going to come?